In this video, we're looking at proving a sum to what's called a sum to product identity. Now, before we talked about a product to sum identity, well, it kind of stands to reason if there's a product to sum identity, by changing things around a little bit, we can get what's called a sum to product identity. And that's what's happening here. Now, turning around kind of twists things, and they don't look nearly as nice as probably the last one did. But we're going to prove this. And the idea behind proving it is you need to use something we already have, and in this case it's a product to sum identity. More specifically, we're going to use the one that we had already proven in the previous video. Now, I have made a small adjustment to this. Instead of using alpha and beta, which might have got a little confusing with the alpha and beta in the formula we're trying to prove, I switched alpha and beta out for x and y. And hopefully that'll make things a little clearer. So what we're going to do is, much like we did before, is start with the more complicated side. In this case, again, the right-hand side. We're going to take that formula and we're going to plug that in for x and y in this formula, the one that we've already proven. So we start with that right hand side and we plug that in. So it's -2 and then sine alpha plus beta over 2 sine alpha minus beta over 2, again going in for x and y. It'll be 1/2, and then in the quantity cosine x minus y, x is being replaced by alpha plus beta over 2, and then minus y, which will become alpha minus beta over 2. And then the same thing in the other one, minus cosine of x plus y, so cosine of alpha plus beta over 2 plus alpha minus beta over 2. So now we're going to take, of course, -2 times 1/2, which just be -1, and now in both these cases I have a common denominator. Now in the first one I have to distribute the negative sign through, so of course I have alpha plus beta, and then that'll be minus alpha, and then minus a negative beta will become plus beta. That'll all be over my common denominator of 2, and then likewise the same way. I'll have alpha plus beta plus alpha minus beta all over 2. So now to carry this out, to finish this problem off, notice in the first term there the alphas will cancel out. That'll actually leave you with beta plus beta, or 2 beta over 2. 2 beta over 2 of course becomes just beta. And here the betas cancel out. I have alpha plus alpha, which would be 2 alpha over 2, but again the 2's will cancel out, leave me with just alpha. So now I have -1 times cosine beta minus cosine alpha, and now distributing and just rearranging, I get cosine alpha minus cosine beta, which is exactly what we want it to prove. That cosine alpha minus beta is equal to -2 times sine of alpha plus beta over 2 sine alpha minus beta over 2. Now, the product of sum identities that we talked about before are useful in calculus. The sum to product identities are useful in a more algebraic sense in solving equations. And so we use these when we're trying to solve equations involving trig functions that have 2 different angles. This one will be useful for something where you have a cosine of one angle minus a cosine of a second angle. Usually it's best if it's equal to 0. Again, not a difficult identity to prove. Once you have it set up right, keep track of the fractions. The main thing to realize is that you need to have this particular product of sum identity that you need for that one.